Hi everyone, welcome to the last lesson in Unit 2. Today we'll be working on Unit 2, Lesson 6, Inverses of Functions, page 74 to 79. Make sure you have the right notes out. Let's get started. Take a moment and work on the opener. Pause the video here, please. I will show my answers in a moment. Okay, so this was a review from the last lesson. So if this was difficult for you, go back to the lesson before. So I composed the functions f of g of x, did my simplifying, and I got f of g of x equals x. Moved over here, same thing, just switched them around, did my simplifying, and I got g of f of x equals x. Just gonna point out right here, domain, this is a quadratic, so it's all real numbers. Here, it should be -4 to positive infinity because I can't have any negatives in there. Okay, and it says, what do you notice about these two functions? They both equal x, and they now have the same domain. And remember, guys, you can write this like this with your positive infinity, or you can leave it blank, or not put the positive. So today we are learning about inverse of functions. Functions that undo each other are called inverse functions. So getting back to x. So in the opener, those were actually inverses. We solve for the inverse functions by switching the roles of x and y, and you will literally switch x and y in the math, you'll see that. Because inverse functions interchange the input and the output, the domain and range switch. So the domain becomes the range, and the range becomes the domain. So there are two types of questions that we can ask involving inverses, and it's solve for the inverse and are these functions inverses? So these are the types of questions we'll ask. If you're confused about this lesson, this is where you want to go back. This box will tell you everything. We are going to focus on the second question right now, asking if things are inverses. So since they undo each other, we can use our knowledge of function compositions to help us figure it out. So two functions are inverses if both of the following compositions are true. F of g of x equals x and g of f of x equals x. So I'm like, this is probably one of the biggest parts of the lesson. So this is like, pay attention there. So if you check this and you don't get x, you don't even have to check this. Like, you only have to do half the work then, because you already know if it doesn't work for one, it's not going to work for both, or it doesn't matter because it has to work for both. So let's try this out. Let's see if they're inverses. So I'll do my colors again. I really liked that. And I have my green highlighter here. So f of g of x. So I see the g of x on the inside. So I'm going to go to f and plug in the green. So this becomes 5 times something minus 2. And in there, I put my equation. That's a 5. Okay, let's do some math. So right now, we're trying to get it equal to x. So 5 times 1/5 is just 1x. 5 times 4 is 20. So right now, I can already tell this ain't gonna work because of this 18. I want it to just be x. So I can already say no. And you don't really even need to check this, but just for the sake of practicing compositions, I'm gonna show it to you, but after this, you don't have to. G of f of x equals, so I go to G, and where I see the x, I put my space, and I know my blue line's gonna go there. So that would be x plus 2/5 plus 4. I already know that this ruins it for us. So these are not inverses because f of g of x does not equal x, and g of f of x does not equal x. So we're done. But if we had done these and they would have been just x's, they would have been inverses. So we'll get to an example like that. Okay, next page. It says, determine if g of x and f of x are inverses if f of x equals 3x squared minus 5 and g of x equals x, the square root of x plus 5 over 3. When you look at these, I see a squared here and a square root here. I see a minus 5 and I see a plus 5. I see a multiplied by 3 and I see a divided by 3. So it looks like intuitively, I'm like, oh, that's a lot of undoing. We're undoing a lot of things. So I'm going to make this one green and this one blue. So looking here, I'm going to take I'm plugging in blue here. So f of g of x, I'm going to go to the green one, so f. I make my outline, and I know that the blue will go there. Okay. The square root, if I square a square root, it goes away, which is great news for us. These 3's cancel out because 3 over 3 is 1. This feels good. Those go away. So we get f of g of x equals x. Woo! So now we can't say yes yet, but now we just check this one, and if we get another x, then we're good to go. So this is saying we're going to plug in the green to the blue. So I write the square root. I know it's going to be something plus 5 all over 3. And then I put my green here. So that will be 3x squared minus 5. So let's start doing this algebra. So minus 5 plus 5 becomes 0. So we have 3x squared over 3. That just becomes the square root of x squared, which is x. So we have g of f of x equals x as well. This is good news. So these are inverses because f of g of x equals x and g of f of x equals x. And I kind of had that intuition here because all of these were undoing each other. Multiply by 3, dividing by 3, minus 5, add 5, squared, square root. So the more you do these, you kind of get an intuition for them, but it takes a lot of practice. Okay, next problem. Let's get my colors. This will be green. This will be blue. So f of g of x means I'm going to plug in my blue to f. So I write f down. And this will be 1 over something plus 2 minus 3. So look, I got all the pieces of f of x. And now I just have to write this in. So looking at these don't really look like full opposites. They look like they just switched the 2 and the 3. So let's go for it and see what happens. So simplifying the bottom, the 2's go away, and I'm left with this. So let's see. So this is 1 over x minus x plus 3. I apologize. So if you copy dot flip, this just becomes x plus 3 minus 3. Oh, look, guys, it worked. Okay, that one worked. Let's see if the next one works. Just because this one does, doesn't mean this one will. Okay, so now I'm going to plug in my green. So I'm going to write down G, the outline of it. 1. So see, I got all the bones of G, the 1, the 3, and the -2. And right here, I'll put the green. Oh, I didn't put that one there. There we go. So this will be 1 over x plus 2 minus 3. Okay, now I'm kind of having a feeling. I'm like, oh, I think I see it, right? The more you do these, the better you are at getting the intuition for them. So that becomes 1 over 1x plus 2. These 3's go away, minus 2. When you copy dot flip this, you get x plus 2 minus 2. Those go away, and you get g of f of x equals x. So my intuition at the beginning was wrong. I was like, oh, they just switched these. But when you did the copy dot flip, you were able to eliminate the constants. So yes, these are functions. And you can say both compositions equal x. Pretty neat. Okay, guys, that is all we have for the notes. Thanks for listening. Make sure you write down any questions you have for your teachers. Have a great day. See you in class.